All right, so today's lesson is going to be on standard deviation, really a skill that a lot of my students struggle with, but after this, hopefully you won't. Let's take a look at how standard deviation works. First of all, typically mathematicians aren't that good at naming things, but here actually they are. Standard deviation, the deviation from the standard, really the change from the mean. And let me show you what I mean. So think about your high school. At your high school, I'm sure there are some 3-foot people, some 4-foot, mostly 5-foot people, some 6-foot, and then maybe one 7-foot basketball player. If you took a look at where the mean is probably right around here, maybe like 5'1" or something like that. Just hypothetical, just go with me on this. From there, for me to encompass a majority of the people, I have to stretch the arms of this really from the mean. Again, this was the mean. I have to stretch my arms maybe up a foot and down a foot, really, to encompass 68% of the population. That's an important percentage for standard deviation. Again, to encompass 68% of the population, I have to travel up a foot and down a foot, perhaps. Then, for me to encompass 95% of the population, I have to travel up 2 feet and down 2 feet. And again, that's 95% of the population. For me to encompass 99% of the population, I have to go all the way out here, really up 3 feet and down 3 feet. So what you're learning here is that standard deviation is all about the spread of the data. Really, from the mean, I had to travel up and down a foot to encompass a majority of these people. Really, these percentages are important: 68%, 95%, and 99%. In this case, my standard deviation was 1 foot. I had to go up 1 foot and down 1 foot, up 2 feet and down 2 feet for 2 standard deviations out, and up 3 feet and down 3 feet to encompass 3 standard deviations out. And that's your high school. Come with me over here to the NBA. What is the NBA? Well, in the NBA, everyone's super duper tall. Really, what's their chart? What might their chart look like? I don't know much about sports, but I think it might probably look like this. Really, zooming in over here, this is the NBA. And if I asked you, what's the mean of this data? Well, I don't know, maybe the mean of this data is somewhere around here. Maybe like 6'8" or something like that. But who cares? What you're going to see is that, do I have to travel very far to encompass 68% of the population? Not really. Maybe I just have to travel up and down 3 inches. So really up 3 inches and down 3 inches to encompass 68%. Whereas to encompass 95% of the population, I could travel up 6 inches and down 6 inches. And now again, cover 95% of the population. Now imagine that I'm encompassing 99% of the population, maybe up 9 inches and down 9 inches. Really, this would cover 99% of the population. Hopefully what you're seeing here is that, oh, my standard deviation here is much, much smaller because the data is so tight-knit. When the data is much more tight-knit like this, do I have to travel as far? No, I just have to go up and down 3 inches. Really, the standard deviation in this case is 3 inches. I need to deviate from the standard 3 inches up and 3 inches down to encompass 1 standard deviation out, to encompass 68% of the population. So if I were to ask you a quick question, which set of data is more spread out versus which data set is more tight-knit, really more wrapped around the mean? Hopefully you would say your school is more spread out. Hopefully you would say the NBA is more tight-knit. Thus, your school has a much bigger standard deviation for heights, whereas the NBA has a much smaller, much more tight standard deviation for their heights. So that's my quick little introduction. I'm going to move down here to some actual questions so we can apply it and learn. Come over here for a real ACT math question. I think this was a number 60 on an ACT. But now it's a joke. Watch this. Blah, 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 blah. 2 standard deviations. Wait a second, within 2 standard deviations, how much are you going to encompass? Remember, I said 68 is 1, 95% is 2 standard deviations out, and 99% is 3 standard deviations out. I have seen them test all 3 of these percentages on the SAT as well. Thus, 2 standard deviations out, which one do we like? 95, D. Easy one. Come with me over here to number 59. I'm going to give you guys a second to try this one now. If you can get this, I'll be super impressed. It says, which of the following data sets has the greatest standard deviation? Well, what did we say earlier with the NBA? The NBA was all tight-knit, so it's small. Whereas your school was very spread out, so that had a very big standard deviation. Thus, if I'm looking for the greatest standard deviation, is it D? Is there much deviation at all here? No, there's 0 standard deviation. What about E? What about B? Actually, B and E have the same amount of deviation from the mean. Therefore, it can't be either of those. Those aren't deviating all that much. Take a look at C and A. A lot of my students choose between A and C on this question, but I want to make sure you get the right answer. It looks like the mean here is 8. Am I stretching all that far from 8 to encompass 6 and 10? No, not that far, really up and down too. Whereas what's the mean here? Something like 5 point something. In that case, am I stretching very far to encompass 10? Am I stretching very far to encompass 1? Yes, I am. The answer, my friends, is A. A is the most spread. I love using that word for standard deviation. That's good there. I want to come to our last question of the day, and that is going to be this one right here. Again, I would ask that you guys pause the video here and try, but I am going to show you a beautiful way to think about this one. This is, again, a real ACT question, and I'll get started if you don't want to pause the video here. The idea behind this question is you have a group of kids at a daycare. It says, which of the following gives the mean and standard deviation of the ages of the same children 5 years later? So you have the same kids currently, and then 5 years later, what happens? Well, I think about just trying numbers. Imagine my kids at the daycare are 1, 2, 3, 4, 5 years old today. Okay, that's cool. But then in 5 years, really, I'll say 5 years later. Obviously, you don't have to write this when you're doing the question. I'm just trying to help you. This would be 6, 7, 8, 9, 10. Oh, they got 5 years older. In that case, if I asked you a quick question here, did their mean increase? Their mean was 3 before and their mean is 8 now. Yes, their mean definitely increased. I would say M plus 5 for the mean. I definitely like H, J, or K. But now, let me ask you a question. Did their spread change? Did the amount of spread or deviation from the mean change? Did I deviate? No, just up and down 1, up and down 1. Did my deviation change? Not at all. Really, the S stays the same. I love answer choice H. This is kind of a tough one, but when you visualize it like this with a real proper example, it makes it so easy. Anyways, boys and girls, that is it for this quick lesson on standard deviation. I hope that helped, and if it did, please do me a favor and like, share, and subscribe, and I'll see you guys on the next one.